We want to turn string A into string B with as few operations as possible. Insert adds one character anywhere. For example, cat becomes cart by inserting R. Delete removes an existing character. Replace changes one character into another. Each operation costs 1. Only these 3 edits are allowed: insert, delete, and replace. How many edits turn horse into rose? When characters differ, branch into insert, delete, and replace. 3 choices make the recursion tree explode. Dist I-1j deletes the last character of A, so I decreases while B stays unchanged. Dist ij-1 inserts B's last character into A, so J decreases while A stays unchanged. Dist I-1j-1 removes the last character from both prefixes, replace if they differ, or match at no extra cost. Each prefix pair can be recomputed. A matrix remembers it. The state lives at the intersection of 2 string prefixes. dpij is the minimum edits needed to align 2 prefixes. Every cell stores an answer that can be reused. If characters match, no new edit is needed. Move diagonally. If they differ, try insert, delete, and replace. Add 1 edit to each path and keep the smallest result. Fill the empty string boundary first. Only deletions are possible. The first column is symmetric. Insert characters from the empty string. For an interior cell, compare the neighbors for all 3 edits. Fill left to right and top to bottom. The bottom right 3 is the answer. Horse, horse, hos, Ross. Deleting E, deleting R, then replacing H with R. Edit distance unifies 3 edits in a 2D matrix. Horse becomes rose in 3 steps.